So my name is Jimmy Bogard. You can find me on Twitter at @jbogard. My GitHub is the same, github.com/jbogard. And so this talk, all the code and everything is also going to be on my GitHub, which I have a link at the end as well. I blog about this topic quite a bit on my blog at jimmybogard.com. That's a bunch of other junk about me. My day job is actually working at a software consultancy out of Texas, where a lot of the code from this talk came out of a project, which I'll talk about here in a second. So for a lot of my career, I didn't have to worry about things like distributed transactions. Like most of the time, the systems that I built were just kind of web apps, right? You have a web app that talks to a database, and usually everything works just okay with that. And so in that simpler time, I just had an app that did stuff with a database. And if I wanted to change information in the database, I could just do an update statement. And if I read the information back out, like I have a reasonable expectation that what I just wrote, I can read back out of the database because it's a database, right? So like everything is good in this kind of world. I could do multiple operations as well. So I could do things like issue 2 updates at once. Now, if something were to go, and I can read everything out, and everything should be okay again. Now, if I do something and something goes wrong as part of this, like something happens with the second statement, ideally either both operations happen or neither operations happen. And I can do this if I wrap those operations in a transaction. And if I wrap things in a transaction, either all the statements succeed or all the statements don't succeed. So as long as we practice like normal good practices of like doing things in transactions, then all my normal systems work as expected. Now, the first time I ran into distributed transactions was kind of a slight wrinkle to this picture. Most of the systems I work with have like the app and the database. But in this picture, I had not one database, but 2 databases. And so instead of having both updates go to one database, I would have one database for the sales information and one database for the stock information. So if I issue those 2 updates and try to put those in a transaction, everything works, right? Yes, I hear laughter. No, it does not work. It doesn't. You get this really horrible error message that comes out, and that's your first kind of punch in the stomach. Like, oh, I've never seen that message before in my life. And then you go Google it on Stack Overflow, and there's all this very distressing and awful questions about all the things you have to turn on, and basically come down to, if you want to have a transaction between 2 different databases, then you have to use something called distributed transactions. I'm like, okay, what is this? What is this will this solve all my problems? And so a distributed transaction is just a transaction in which 2 or more network hosts are involved or resources. And there's a lot of different protocols to do this. The most common one is known as two-phase commit or 2PC. And the way it works is this. Instead of you having a transaction that works exactly against one individual database, instead you have to have something else on the side here that has to coordinate the transactions between these 2 resources. And it's called two-phase commit because it works in 2 phases. The first phase is prepare, which is basically asking each resource, can you perform this operation? And each resource responds back, yes or no, I can do this thing. They get feedback to this central coordinator. And then once the coordinator receives the feedback from all the different resources that are part of this distributed transaction, it says, okay, now you're good to go. Go ahead and commit the transaction for each of the individual resources. Now, this picture isn't bulletproof. This protocol isn't bulletproof. Something can actually happen in the second phase of the commit. So if like the first arrow succeeds and the second arrow fails, I'm actually in a partial succeed, partial fail scenario. So that's when you start to have like 3-phase commit and 4-phase commit and like just adding more phases. But the problem eventually comes, you cannot guarantee this transaction between these 2 resources because you have this problem of the communication of other resources on the second phases can still fail. So if you want to do this, you can do this. Today, Microsoft has an implementation of this protocol with a Microsoft Distributed Transaction Coordinator. So this thing can perform transactions between 2 different SQL Server instances. It is a huge pain to set up. And if you ask your operations folks to do this, they will give you like the meanest looks and be like, you're asking me to do what now? You have to open all these wacky ports between all these different places, and they will hate you for it. You have to make sure that this Distributed Transaction Coordinator is also highly available and and these arrows between these 2 resources aren't very long. So if I have a long communication time between these different resources, then that will increase increase the likelihood of failure. But if you get all those things up and going, the ports and all that junk, then this can work for you. Unless one of those instances is in the most expensive checkbox in the world, SQL Server always on. If you check that box, then there is going to be a primary and secondary of one of the SQL Server instances. At this point, you can't do distributed transactions anymore. Or if you're in Azure, you will get a lot of laughter from the Azure folks if you ask, hey, can you go ahead and turn distributed transactions for this? And they'll just laugh and laugh because no, this is very hard to set up on their network, and so they're not going to allow you to do this sort of thing with their stock SQL Server instances. Now, if you host these instances in virtual machines, then you can do it, but don't do that. Don't host SQL Server in virtual machines on the cloud. Just use the cloud providers there. You can do messaging and database stuff, provided that your messaging is MSMQ, the thing that comes with Windows. That works, but it doesn't work if you're using anything else, basically. Anything else besides MSMQ, you cannot coordinate a transaction between a database and that queue. Also, for a lot of NoSQL databases, you can't perform transactions against multiple items. This really depends on the database itself. So like MongoDB now allegedly supports transactions between multiple resources, but Cosmos DB does not. And a lot of other NoSQL DBs don't allow you to do this either. So just to sum things up, I can do two-phase commit transactions within a single resource. That's possible. Transactions across identical resources, not really. Transactions across disparate resources like a database and a queue, definitely not again. And then transactions across multiple items, even if in the same database, basically have yes SQL and NoSQL, the ability to do that. So the example that I'm going to be holding on is one that came from a client in which they were using a document database, MongoDB at the time, but eventually they moved to Cosmos DB, and RabbitMQ. And their code was basically like, they needed to fulfill orders as part of an online e-commerce application. And in this, they were consuming messages from RabbitMQ. They were issuing multiple writes to Cosmos DB, producing messages back onto RabbitMQ, all within a single transactional activity. And the code they started with basically assumed that everything is going to succeed. But one of the things that I noticed with distributed systems is that they often fail. And if we don't code for failures, then bad things will happen. So the code basically looked like this. They were reading information out of the Cosmos DB, and then they'd issue their first update to say, I need to approve the order. Then they would loop through all the items in the order, and then deduct stock from them, and then update the stock for each individual stock item that existed on the order. So this could be one update, it could be a dozen updates. However many things you ordered, I would be deducting stock for each of those. And then finally, I'd go ahead and publish out an event on RabbitMQ to say, hey, the order's been approved, go ahead and do additional stuff. Now, at any point in time, if anything fails in this picture, I'm going to have a partial succeed and partial fail scenario. That is, if something goes wrong with stock here, let's say I don't have enough stock, which you don't see in this code, of course, but let's say I don't have enough stock, and I'm like, oops, I don't have that, so I can't actually fulfill the order. Well, I've already updated the order, and that transaction is complete. Or what happens if RabbitMQ is down for some reason, and I'm not able to publish that event there at the end? Well, all the other updates have already happened, but I'm missing this last external update there at the bottom. So I saw this and said, well, we know that we can't just put this in a transaction. That's not possible. Cosmos DB does support some level of multi-record transactions, but you have to use store procedures, strike one. The store procedures have to be written in JavaScript, strike 2, 3, 4, 5, 6, 7. So well, we don't want to do that, especially because they still weren't sure if they were going to go MongoDB or Cosmos DB, so they don't want to put too much into very provider-specific stuff. So they said, we can't really do this. We can't do the data updates in a transaction, and that doesn't also allow us to do the messaging as well. So we need some solution to be able to perform all these operations in some kind of coordinated activity. So after being presented with this problem, you do a lot of Googling, right, to see other people surely have come up with, have had these problems. And a lot of people have, but I didn't see a lot of solutions. There was one great paper from an employee at Amazon, Pat Helland. He was actually one of the original designers of Microsoft Distributed Transaction Coordinator. And this guy's life beyond distributed transactions, and Apostate's opinion, that basically says in real applications at scale, this two-phase commit doesn't really work. So how do we design systems where we still need to have coordinated activities, but we can't wrap everything in a transaction? And so Apostate is like someone that used to believe something but doesn't anymore. So like the guy that designed distributed transaction coordinators, like, don't use it anymore. And this was his paper describing how to do it. And his epiphany is basically that we need to assume that our transactional boundaries are against a single item. And if our transactional boundaries are against a single item, then I need to have some way to coordinate activities between multiple items. And the way that he did this is pretty clever, I thought. He stored messages to other different resources inside of that same row or entity inside their database. So if I wanted to interact with some other thing, then I would store the messages to that other thing inside of myself, so that the transaction was not just my business data, it also included the messages I was intending to send to other parties. So I could have multiple messages coming into my entity, and these aren't like RabbitMQ messages, these are more like logical messages versus like something I put in Kafka or RabbitMQ or Azure Service Bus, something like that. And the idea is that the entities will remember these messages and the activities that have happened, so that if I get the same message delivered multiple times, I have a way to look up and say, nope, I've already done this before, no need to do anything else. Look at this lovely picture of like, look, I have these messages going to these different things, and like these little circles and arrows, and everything is absolutely happy. The problem we hit, though, is that there's no code to this paper, just pictures. And everything I found online was just also more presentations with prettier pictures and better animations, but like no code telling like how to actually do this. And as far as I can tell, I didn't really see a lot of people coming up with robust solutions around this overall problem. So going back to Cosmos DB or MongoDB, each of those has transactions around a single document boundary. So as part of that document, we would include the business data associated with whatever we were doing. So that's kind of the normal documents we'd create today. And I have multiple documents. Each of them has their own individual business data. Now we're going to add on top of this a means of communication between different documents. And each of these will be called outboxes. So a document has its own business data and outboxes as a means to communicate to other documents. And so the messages I want to communicate will be stored in that document in that outbox. Now, in order to receive messages and process them transactionally, I need to have that memory of what's happened before, and that memory will be an inbox. So the inbox will also include messages of what it's received in the past, so that if it receives the same message twice, I can go look at my inbox and say, oops, nothing to do, I've already processed that message. And because my transactional boundary is an individual document, then I can store each of these messages, inbox and outbox, and then have things around it in order to facilitate actually dispatching messages to other documents. So with this basic picture in mind, we still had to work within the confines of like what Cosmos DB and MongoDB could handle. So my messages had to have some kind of type information, and we started off with just a basic interface. I have a document message, and its basic property it needs to have is some way to identify this document message versus other document messages. And this is how I tell between one instance of a document message and another. My base class would include, for an individual document that can communicate with other ones, it includes the inbox, which is just an enumerable of document messages, an outbox, which is, again, a set of document messages, and some methods to help facilitate working with the inbox and the outbox. Now, sending a message to another document, and that send method is really just adding a message into my own outbox. So it's not actually like sending a message on the wire or trying to like use RabbitMQ or anything like that. It really is just add a message to the list of messages in my outbox. So using this will look something like this. In this case, I'm creating an order request. So basically, I'm clicking the button on the checkout page, and I'm passed in a shopping cart. And as part of that, I need to create an order request. So it has all the sort of business data that you'd kind of assume would be on an order request. So I'm pulling information off of the cart, things like getting the line items off of there, setting the status as new. But as part of this, I now need to kick off the order fulfillment process. And to do this, I will need to send a message to the other documents. And in this case, I would just call the method send, passing in an order created document message that has the ID of the message, the order ID of which I'm trying to fulfill, and then in this case I need to deduct the stock for everything, and so I'll have line items that represent each of the different items that I need to fulfill for that stock. Now remember, this is not actually sending a message anywhere. It is just adding this order created instance to the list of outbox. So when I save this document, it's saving the business data along with this message in its own outbox on its own document. So now that I've got a way to send messages, I need some way to actually dispatch the messages out of the outbox of these documents and to the inbox of the receiving documents. And so we'll do that via a dispatcher. The dispatcher is going to be the thing that pulls messages off and then dispatches messages to individual documents. So the picture looks something like this. We have 3 documents that are part of a kind of a logical transaction, but remember, I can't make all of these documents part of a single database transaction, so their messages are going to be the thing that coordinate activities between these different documents. So the first operation is when you write some data to the initial document and write some messages to the outbox. That transaction succeeds, and again, at this point, that document is done, and it's been saved to the database successfully. My dispatcher then takes over and says, right, looks like I've got a document that has messages in its outbox, so I'm going to pull the message out of the outbox, find who are the right documents that should handle this, and then pass those messages to each individual document to be able to handle. So I'll find these 2 documents that I need to receive them. I will pass the message in, and as part of processing that message, it will do whatever kind of data manipulation it needs to do, like the business logic, and it will store that message that it's received in the inbox. And then that transaction succeeds. So the dispatcher is pretty straightforward. I have an interface that just dispatch messages for this document. I still need something to actually handle those messages, so we created an interface for the handler of those document messages. And the document message handler, what this logic needs to do is based on an individual document message, it needs to figure out which document needs to receive that message and then delegate to that document to be able to handle the message. So these look pretty simple. It's basically like load the thing out of the database, pass the message to the document, and then save the document, and then we're done. The dispatcher will basically loop through the messages in the outbox. It will find the handler for each document message in that outbox. It will delegate to that handler to say, okay, now handle the message. Here's the document message you need to do. And then it'll complete the message on the original document and then finally save the original one. And I'll show a picture of this last 2 here in a second. So an order, in this case where I'm receiving the order created and I need to create this fulfillment document to fulfill the order, this is the document message handler, and it will find the order fulfillment document out of the database. It will delegate to that handler, to that document, to say, go ahead and handle this message, and then finally update the thing. Basically, all my document message handlers look just like this. It's just load the thing, call the thing, and then update the thing, and then we're done. Now, handling is a little bit special because instead of me just having the business logic by itself, I will call this special receive method. And that receive method will be passing in the message itself, and then I'll have the actual business logic as a callback. So this is like doing all the business logic to say if the order's been created, and as part of that, I can also send additional messages to other folks. Now, the reason why we have this separate receive in the inbox is for when things go wrong. And again, because I've had so much experience with failed distributed systems that on the top of my mind always is like, what happens when things go wrong? In this picture, that is any one of those arrows that I was drawing earlier, what happens when one of those arrows, something blows up there? So here, I'm in the middle of dispatching a message from one document, and now I'm ready to go dispatch to the next document. However, something goes wrong with that second document. So something fails, we don't know exactly why, just like something messes up for whatever reason, maybe it's a bug in the code or whatever, but I needed a way to be able to basically retry this operation again. So when the dispatcher detects a failure in one of the documents to be able to handle, then it will have a passive retry and a retry queue. So this is like a RabbitMQ queue that says, okay, I'm going to try these operations offline. So retries. I need to be able to, since I don't have a transaction, right? I can't just like retry the entire operation. I have to be able to pick up where I left off. And so picking up where I left off is saying, okay, I need to retry the document messages in the outbox for that document up there. And so it'll perform the same operation again. It will read the messages from the outbox and then dispatch them to each individual document. Now the first one has already processed that message. So we need to make sure that it doesn't process it twice. And that's the purpose of that inbox. The inbox is that memory of the things I've already done. And so in processing it, it will just check to see, have I already seen this message before? And if I have seen this message before in my inbox, that means that I've already performed this operation before. And so there's nothing to do. It's just like, nothing to do. I've already done the thing you asked me to do, so we're good to go. A second one hasn't processed that message yet. So as part of its work, it will do its business logic, set whatever data it needs to do, and store that message in the inbox. And finally, the second part then completes. So this dispatcher notices like everything that I've tried to dispatch to has succeeded. So I can go back to the original document and say, okay, go ahead and complete that message, which is just removing that message from the original outbox and then updating it to say, okay, now that overall operation is complete. So it is a lot of like moving parts and pieces here, but this is the only way we can facilitate reliable coordination when it can only deal with one transactional resource at a time. So that receive method on my document base class will just look to see, have I already seen this document message before? And if the document message is in my inbox, then just return. Otherwise, perform the action you were telling me to do, and finally add that message to the inbox. Back in my dispatcher, once all the handlers have completed successfully, then I'll go ahead and complete the document message in my original document, which is just, again, to remove the document message out of my outbox. Okay, so I've got now a way to coordinate activities between different documents through these inboxes and outboxes. Now I still need something that actually calls the dispatcher. And this dispatcher, the way that we designed it, will just dispatch one document at a time. But if I'm dealing with multiple documents or an operation that has lots of different things going on, for example, let's say I've got a document that has two messages, but then those documents also have other messages and other messages and other messages. We need a way to be able to track all these different documents that have been changed and have messages in their outbox. And so for this, we actually introduced the concept of a unit of work. A unit of work will actually keep track of all the documents that have been changed as part of one logical button click on the UI, and the unit of work will then loop through all the documents that it finds the things that have things in the outbox, and then we'll dispatch those document messages one at a time until everything completes. Now, if something does go wrong at some point in the picture here, then again, we'll just say, let's go ahead and retry that one right before it, and that one individual document that failed will have its one outbox retry, but everything else then can succeed. So the retry will just perform the entire operation all over again, and then eventually we'll get to the one that actually will succeed, and then everything should be good. As part of this, we had to, I normally don't like introducing repositories if they're already there. But in this case, we did need to introduce a repository to be able to keep track of what things were being manipulated. So we had a repository that allowed us to have a single entry point for getting documents out of the document database. And this would register them in my unit of work so that when I completed the unit of work, then all it was doing is finding all of the documents that have messages in the outbox, and then dispatch each individual document. And if anything went wrong with that one, then I just skip it and try to make as many as I could possibly succeed. So the idea here is that instead of just failing on the first item, we said we'll try to have as many that can succeed as possible, and then only retry the individual ones that failed. Okay, so again, my failure hat on says, what happens if something really goes wrong with this picture? That is, what happens if something during the dispatching, and I'm trying to write to the outbox, or if something goes wrong and I'm trying to go write that message out to the retry queue, and that fails, how can we recover from that? So somewhere in the picture here, something goes really wrong, but something then fails in my unit of work, and it can't get that last step of pushing out to the retry queue. So in that case, we'll actually have a catch-up process in the back end. And this will depend on your database, but basically we have something that checks for documents that still have messages in their outbox and then still process them. In the case of Azure Cosmos DB, it has these concepts of triggers, and so we can execute a trigger based on any document changing that will look to see if the messages in the outbox need to be processed. And that trigger, we can actually give it a delay. So we could say, like, don't look for these things right away, wait like a minute or 30 seconds or an hour, I don't know. So we're not having contention between the trigger and the unit of work, both trying to complete the individual document messages. So that trigger will say, okay, it looks like something still needs something to be processed, and so I will go ahead and generate the message in the retry queue. Now that code for the trigger is really ugly, so I'm just going to show the most important part, which is basically just like the overall unit of work. It's looking for documents that have changed. We get a read-only list of documents, and if the outbox has any items in it, then we're going to go ahead and send a message to RabbitMQ to say, go ahead and process the document messages for that document class. Okay, so with all this in place, we needed to go back and revisit the design of our original order fulfillment button click that was trying to do way too much in the context of a single click, assuming everything would succeed. And so we needed to have some way to coordinate all this activity. And so for that, we wound up actually going with something known as Sagas. So the general idea is that I have this complex business logic that says an order can be fulfilled when the request is approved and the stock is confirmed. So if I have enough stock and then a business, someone from the business has approved the order, when all of those things are true, then we can go ahead and fulfill the order and ship it out the door. Now, I can't do this in the context of a single database transaction, so we're going to be designing documents to manage the coordination between each of these different resources. Now in my head, when I'm designing this, I actually picture each of these documents as a person. Like they're a person at a desk, and at their desk they have an inbox and an outbox. And they're only responsible for the information that's on their desk, and if they want to coordinate with other people, they're going to be sending messages out the door. And when they get notified from other people, they'll be processing those messages in their own inbox. So I'm imagining just like three people trying to coordinate to perform this transaction. I have the finance folks that are processing, or sales folks that are processing the order request. I have the shipping folks that are dealing with stock. And then finally, I have somewhere in fulfillment that's actually managing the order request and the stock and having all the fulfillment logic as part of it. So this picture starts off with receiving the order request when the customer actually clicks the button on the UI to say, go ahead and create the order. That results in a message that says the order's been created. Now our order fulfillment document receives that message and is now going to manage the coordination of fulfilling an order. So as part of this, it looks at the order and says, all right, looks like you've got 6 items, so I'm going to go ahead and request stock for each of those 6 items. So I'll send messages that represent stock requests for each of those items. Those messages get delivered to individual documents now on the stock side. So I'll have a stock request for SKU 1, 2, 3, 4, 5, 6, 7, 8, 9, and each of those needs to check its own individual stock and say, do I have enough to fulfill this item? And if so, then go ahead and say, I'll go ahead and confirm that stock for each individual request. Those again are individual messages that now get sent back to the order fulfillment saga that takes those stock confirmations and now waits to see if the order is going to get approved. If the user on the order screen clicks approve order, that'll result in a new message that says order approved that gets sent to the order fulfillment saga. It sees now, looks like I've got all of the stock items confirmed and I've got the order approved information from the UI. So if those two pieces together, I can say, yes, order fulfillment is now successful. I can now send the message out the door to actually say, go ahead and ship the order. And now I can, on the order request side, receive that notification and now mark the status as fulfilled. Yay. Kind of just makes you want to use transactions, right? But we don't, we can't. We're in the land of NoSQL without all these, so this is how we have to coordinate these different resources. So let's take a demo of this. Okay. So in this application, let me bump that font up just a little bit. Boop, there we go. I've got my 3 documents. I've got the order request document with that method we saw before that I create the shopping cart, and the first thing I do is I send the message out the door to say order created. I've also got the order fulfillment document and the stock document. So let's run this and see what happens. And no one is allowed to make fun of my CSS skills. It looks ugly. I did not go to Lemon's talk earlier about making it pretty. Sorry. Okay, so this is going to be running RabbitMQ locally, and Azure Cosmos DB also locally with an emulator. So, blah, blah, blah. At some point, we should see the UI pop up here. There we go. So in this application, I just pulled out the AdventureWorks database. I'm too lazy to create my own sample data. So this is just a storefront on top of the AdventureWorks database that came from Microsoft about how to do entity framework junk. So here we go. I'll go ahead and go to bikes, and I want to look at mountain bikes, and let's add a couple of these to my cart. All right, so I go ahead and view the cart. Now I'll click checkout. Now when I click checkout, this is when it's going to start the process of the fulfillment saga. So go ahead and click that. Okay. So I've got a breakpoint here. This is now my order request. If I look at the call stack here, it's all the way up at checkout. So I've clicked the button to say, go ahead and check out the thing. And now I'm inside my order request to actually do the work. So I'm instantiating the order request, passing the shopping cart. And then at the bottom, I'm going to send a message to say order created. Now again, that's not going to call out to anything behind the scenes. It literally is just going to say, add this message to my outbox. Okay, so I've sent the message, and now my order fulfillment saga kicks in. It says, now I'm receiving the order created message, and this is going to perform the logic of the initial setup of the order. So in this case, what it's going to do is persist some information. It's going to store the line items for the stock information, along with the amount requested for each of the line items. And then for each line item in the order, it's going to send out messages to request stock for however much quantity was in the order. That transaction succeeds. And now I should see stock receive that message for a stock request and do the business logic of saying, if the quantity available, which it looks like I have 98, so that should be plenty, is greater than or equal to the amount requested, which is 2, then go ahead and deduct the stock and send a message back saying, yep, stock request has been confirmed. F5. Now the order fulfillment saga receives that stock request confirmation, and as part of this, it's going to mark that stock confirmed on the line item, and then check to see if everything's good. Inside of that check for success method, it'll look for all the line items, and if all the line items have been confirmed and the order's been approved, then go ahead and send this message out for order fulfillment successful. However, we have not yet received the order approved notification, so this saga will just sit and wait until the order's been approved. So I go back to my UI and view my order. By the way, I won't debug this, it'll just happen like that, right? It's all in memory and just saving documents. So the user doesn't see any kind of delay, because this is still not, these aren't messages on the wire, so I'm not actually going out to RabbitMQ or anything like that. These are all inside each individual document, so as far as they can tell, it's just a series of saves. However, the saves are a lot more intelligent because they're using these inboxes and outboxes to coordinate these activities. Okay, so pretend like we're now the order billing person, and I need to approve this order, so they've charged their credit card and say, yes, go ahead and approve this order. So let's say approve, and as part of this approve, I'm going back to the order request and saying my status is approved, and send a message out the door to notify fulfillment that my order has been approved. So here again we say order approved. Now on the fulfillment side, it says yes, we're good to go, and we need to check for success. Now I can look at all my line items and say, yes, indeed, all the line item stock has been confirmed and the order has been approved, so I should send the message out the door saying order fulfillment is successful. Now on the receiving side of the order request, I can say, unless something has happened in the order in the meantime, then go ahead and set my status as completed. So now back in the user interface. Yay, completed. Hooray, we shipped the order. So in this case, it's not just the single button click that does everything. We have a two-step process. We have the initial order request that's going to perform some stock checks behind the scenes. And then the second part is then going to be someone has to physically approve the order. So we can still, even though we have these document messages going on behind the scenes, we can still mix in the user interface with all these operations. Okay. So that was the happy path. Let's look at the not so happy paths here. And that's going to be an order cancellation. So an order can be canceled when the stock request is denied, like I don't have enough stuff there to be able to fulfill the order, or someone rejects the order request. It's like there's something wrong with their order information, or there's just like, it's this junk or whatever, and say, no, we don't want to fulfill this order, we'll just go ahead and reject it. So the user clicks that reject button. So let's look at the first case here, when stock is denied. Now the tricky part here is that each individual stock item is in its own individual document. So I can't actually check all stock all at once. I'm only checking stock for one item at a time. So in our picture here, where we have those initial stock request messages going out to the stock document, I could have some of them succeed, like the first two could succeed, but the third one, I don't have enough in inventory to be able to fulfill it. So in that case, the stock request gets denied, and it notifies the original order fulfillment Saga. The order fulfillment Saga received these messages and said, we've got a problem here. And so in the case where I have this partial success, partial failure, then I need to return some of the items to stock. Like I don't want to hold on to stock of those first items. I want to release those back into the inventory. So in those cases, I'll have three messages. One, to cancel the order. So that will go to the order request. And then I'll have stock returns requested over to the stock documents. So that way, I'm not holding on to stock for partial order to say, you know what, they couldn't quite fully fulfill this one, so go ahead and release whatever stock I had a hold of. Now, even though it's like the sad path, in this case, the order request still finished. It didn't finish in the way probably the customer wanted it to, with the request getting denied, but it still succeeded. All right, let's look at that. All right, so going back to my application, I'm going to create an order that actually will fail. And I can see how this might fail. If I go over to this is the Azure Cosmos DB emulator user interface, and I go look at my stock items, I've got one stock item, product ID 7701, that has a ton available, 96. But I've like artificially screwed one of them up. This other one, I've only got one available. So if I order two of these, then the overall request should fail. So let's go back over here, go back and look at bikes, mountain bikes. I'll add a couple of these top ones, but also add a couple of these second ones. And I just know that that's the other product ID that will fail. So go look at my cart. Yep, I've got two of this one that should succeed and two of the ones that shouldn't succeed. So when I click checkout, it's going to kick off the order fulfillment process. Checkout. All right, so I'm creating an order request, right? So this is going to send the order created message that's going to be received by order fulfillment. Order fulfillment looks through all the line items and will send two messages out for each individual stock item. So it has two stock requests it'll send out the door. The first one it receives, quantity available is 96. Everything's good to go, right? Got plenty of stock, so I'll go ahead and say stock request confirmed. The second one, though, does not have enough stock. Someone says quantity available is only 1, and the amount requested was 2. I don't have enough stock, so I'm going to send stock request denied back to the order fulfillment Saga. Okay, so in this case, now we've received the first message, which was stock request confirmed. So I'll just mark that individual line item as being confirmed with its stock, and then check for any success, which of course won't be, not all the stock items have been confirmed, and the order is not approved yet, so it's not going to be successful yet. But now I've received the stock request denied message. So now I need to cancel the entire order fulfillment. And so inside of there, I'm going to mark my order fulfillment as being canceled. So if something comes in and needs to know that it's been canceled, I can keep track of that. And then I'll process the cancellation. And processing the cancellation will send a message out to the order request to say, go ahead and cancel the order request. And for any of the line items where the stock has not been confirmed, or the stock has been confirmed, I need to go ahead and return that stock. So I should only have one of those where it's been confirmed. So in returning the stock, it's going to look at the line item, say, yes, I need to request the return for that line item, and then send a message out the door. You'll notice as well that I'm also keeping track on my business objects of things that have happened to know that if I need to process this again or things get out of order, then I can appropriately kind of Humpty Dumpty this back together again about the true picture of where I need to be. So I'm now requesting the stock returned. Initially, I get the cancel order request that says, okay, let's go ahead and just update my status to canceled. And now in my stock, I will need to put the items back on that have been returned. So I need to put the quantity available back on for the ones that I originally held. So now, when I look at the user interface, oh, it's canceled. Wah, wah. Now, all of that happened in that time between the user clicking checkout and it come to this page. It can go behind the scenes and look for all that stock information, and by the time they get to this page, all that has completed, and they can see, well, it's canceled, which kind of sucks, but there you go. Okay, so let's look at our last scenario. The second scenario is when a request is rejected. So if a user goes to the screen and there's enough stock, but they just, for whatever reason, they want to reject this order. So in this case, I get a message from order request saying, not order confirmed, but not order approved, but order rejected. And so now the order fulfillment needs to process that rejection. And processing the rejection needs to see well, where am I right now? Have I had any stock confirmed? If there's been stock already confirmed, then I need to return that stock for each of the individual items that have been confirmed. So in this case, I'll send messages out to stock for stock return requested, and then all the stock that has been requested will then be put back into inventory, and everything is now completed. All right, let's look at that scenario. Okay, so we'll make a new order, but this time I will order something else that definitely has stock, so we don't hit that scenario. So I'll go back to my mountain bikes, add a couple of these to carts, I'll skip this one, and then go to the third one, which should have enough inventory. I'll go view my cart, hit checkout, go through the whole process. Now it's going to do all the thing, getting stock and all that junk. It's been confirmed. This one's been confirmed again. Everything is good to go. And now, on the UI, I'm going to reject this order. Womp womp. Okay, so now my order request is processing the rejection. And in case it's not already done this before, it will set the status of rejected and send a message at the door to say, order's been rejected, now I need to process the downstream stuff. Now, the fulfillment saga receives the order rejected and needs to process the cancellation. So it says it's been rejected, it's been canceled, and then as part of that, again, I need to loop through all of the individual line items where stock has been confirmed and return the stock, which again is just sending a message out the door to say stock return requested. So, I received that first one to return the 2 bikes, and then I'll receive the second one, which is return the other one that was just 1 bike. So back on the user interface, I will see not canceled, but now rejected, because that was the button I clicked there. So behind the scenes, if I go look at my Cosmos DB emulator, and like all Azure UIs, this has had a lot of right scrolling, so I'll try to make this as big as possible. But if I make it bigger, that bottom square, which is what I most want to look at, keeps getting smaller. So maybe that'll be as good as it gets. Okay, so if I go look at like order fulfillment documents, I got several in here. And inside of here, I can see, the business data as part of that document. Like it's canceled, here's the line items about confirmations and returns. And down at the bottom, here's my inbox, which is an array. And that array has multiple values in there of all the messages that have been received by this document. So I can see as part of it, it's received order created. It's received stock request confirmed. Then I got the order rejected message because the user clicked reject order. In the happy path one, I can see order created, stock request confirmed, and finally order approved. So that's that memory. It's just an array that has the messages stored as part of it. And as part of that, it's just an array of those events stored inside of my individual document. Now, what's not shown here is any kind of cleanup process. Like those, especially for something like the stock items, I don't want that inbox to grow forever. So I'd likely have some kind of garbage collection or like decluttering of the inboxes. That probably is like every time I process a message, check to see if I have any old messages in there. Maybe I have based on the number of messages or just the time. Maybe what's a reasonable amount of time to be able to keep track or keep around messages that are old? Is it a day, 30 days? It's really up to you, and that could be done on a document by document basis. So other situations, it's not just like exotic NoSQL databases, although I guess Cosmos DB isn't that exotic, just has JavaScript stored procedures because of reasons. So other situations where we may run into this are cases where we have like two normal resources, so we're not doing anything crazy here, but those two resources cannot be part of the same transaction. So in the case of like having just like normal vanilla SQL Server, but if I try to have an operation that writes to SQL Server and produces a message on RabbitMQ, I can't coordinate those two things together. So this is another good case where we could use an outbox to be able to coordinate the activity of sending messages via RabbitMQ. And so the general approach of doing this is we find the transactional boundaries of whatever business data system we're dealing with. So in the case of something like a NoSQL database, those transactions might be around each individual document. So my inbox and my outbox have to be inside each of those documents. Now, if my document database supports multi-document transactions, then what I can do is just have a single collection for my outbox that I can coordinate the transaction with each of the documents. So SQL Server, for example, does support multi-row transactions, like since forever, right? So in that case, my outbox just needs to be part of the overall transaction of the business data. And so in that case, I can just have a separate table for my inbox and my outbox that is the messages I intend to eventually send out the door via RabbitMQ. So other places we might see this, microservices. If I want to coordinate activities across service boundaries, I cannot have transactions across those service boundaries. I cannot share a database between microservices, right? Right? Yes. So in this case, if I have multiple microservices that each have their own business store, then each of those will need to have an outbox in their database if they want to have coordinated activities across the wire. So in this case, I've got an outbox in my first microservice that wants to coordinate an activity with another microservice. So this is going to use a dispatcher or a translator, put the message on the wire, and the other microservice will do the same thing. It'll receive the message, check to see if it's already processed that message in its inbox, and if it hasn't, then it'll go ahead and perform the activity. This is hard. I would highly suggest not trying to do this all yourself. So there are open source libraries and tools out there to do this. In the .NET land, tools like Service Bus and Rebus and probably a couple others out there, they all support this pattern directly, this sort of outbox pattern. So basically we just say like, enable outbox, here's the connection information to my business data database, and it'll just take care of all of the stuff for you behind the scenes. In our case, in my client, we didn't have any of that, so we had to write our inbox and outbox ourselves. So just to sum things up, some final lessons. Distributed transactions are, quote, easy locally. If I actually run MSMQ and SQL Server on the same box, then like it'll all work super great. But distributed transactions are hard or impossible when you're actually distributed. which is ironic because it's called distributed transactions. So to fix this, we find the transactional boundary of our business data, whatever that boundary we can find, and based on that database, we'll create an outbox and an inbox to coordinate communication between those disparate resources. So that was my life beyond distributed transactions and Apostate's implementation, which now exists. If you want more information about this, you can check out the code up there. It's github.com, Bogard, AdventureWorks Cosmos. That is all the code that you saw today. There's a presentations repository that has all the slides and these animations and stuff. Thank you all very much. I hope you have a great rest of the conference. Okay, so I do see some questions this here. Will DCC work with SQL Server cluster? I don't think so. Is it difficult to maintain this system? To find out what went wrong? Yes. How does your data modeling change with this approach? We have to be able to model those messages, and so I do have to know how my database can actually store that kind of blobs of data. So in SQL Server, it might just be like binary data, and in Cosmos DB, it supports rich, robust JSON serialization, so we can just do that there. What about rollbacks? You saw the rollback. That was the stock request rejection. When we don't have transactions, we have to have compensating actions to be able to wind things back. How do outbox messages get to the right set of receiving documents? Hand-rolled code. There's no other way around it. And this approach increases write operations. How does this affect performance? It affects it. This is going to be a trade-off, right? All this stuff you see here. So you have to decide, do you want the overhead available here, and can my system handle it? Or do I need to handle failures in some other way? But probably not like throwing up your hands. Don't just be like, we'll just hope things succeed. Actually have a real decision around it. That's it. Thanks.